Yeah, so this is the assignment for EE782 using LSTM for stock market prediction. My name is Rohan and my roll number is 20D170033. So yeah, so this is how the assignment goes. In the start, I have made use of the Kaggle API to download the dataset because every time we connect to the Google Colab, it requires you to download the dataset. And using G drive mounting has become difficult after CC has restricted file size. So I'm using Kaggle API. So these are the libraries which I've used, and these are the stocks where you can insert whichever stock you want to include for processing later. So right now I've chosen these four companies, and mainly I'll be focusing on Apple and AMD later. So this function basically takes given a name of the stock and start date time and end date time. It gives you the subset of the data instead of every time putting the entire thing in the data frame from the file. So this returns a subset of the data as a data frame. This function is to visualize minute by minute price. So you can just see here. So I'm plotting from January 3rd, 2020 from 12 p.m. to 12:30 p.m. for each of the stocks. So you can just see left side is the stock prices, right side is the volume. So this function does the same thing, but it basically resamples it by day and then prints the things for day by day instead of minute by minute. So here you can see for AMD, these are the stock prices for the month of January, and this is the volume traded. Similarly for the other companies. For plotting the candlestick chart, I've used the MPL Finance library of Python and basically do the sampling of data and then pass it to this mpf.plot where it has a candle thing. So when this particular thing plots for 2020, you can see here. These are the candlestick plots for various companies for the first quarter of 2020, basically. Yeah. So visualization, after performing the pre-processing, we come to know that there are some missing data in middle of the data. So hence, in order to solve this issue, what we'll do, this might be because of holidays or something. So what we'll do is we will assume that it is connected from here to here, and we'll basically treat the entire data as a continuous time series. This is because anyway we'll be dropping the date columns while training it. Only in the case of the last question, the ninth question, the bonus question, there we'll be putting in the data values also, the date time values also. That will consider separately. So for normalizing, we have used two particular strategies. One is the min-max based scaling and Z-score based scaling, which is basically both of which we'll use the sklearn.preprocessing library. Here it basically concatenates all the chosen companies and then performs a fit and then transforms the data into the appropriately scaled thing. So for example, this is for min-max scaled data points for AMD, so you can just see it from 0 to 1. Similarly for all other companies, we have done the scaling. And important point is that we'll be scaling the prices in one scaler and the volume in a separate scaler. So that because of their variation in the thing. So similarly, do the same thing using Z-scaler. We use standard scaler library for performing Z-score based scaling. So this is the visualization after performing the scaling. To choose it, so the assumptions that I made in this particular part is that I'll be performing high frequency trading, and we trade after a set time of m minutes. So for example, later I'll show you that I've done a trade every 10 minutes, and the company that I'm choosing are from the tech basket, which is basically Dell, Cisco, Apple, Amazon, Adobe, and so on. But we'll be focusing mainly on Apple and AMD. So you can see this also later. And also we assume that there is bias, spread, and commissions. So what we'll do is we'll take the commission per trade to be $1 and the bias spread is 5 cents. This is as per the values which I found online for high frequency trading. And since I'll be doing high frequency trading and the Z-score based scaling has shown better as per the internet, it says this is better. I'll be following the Z-score normalization to use this. So yeah, for the PyTorch implementation, I followed this reference and used his architecture of the LSTM, which is implemented in PyTorch. The reference is here. So and the strategy that I use to combine various company stocks later, as you will see in the bonus part, basically I'll take the data frames and then perform an inner join on them. So for example, here this is the data for Apple and Amazon, and then for the given time, so for 4 o'clock is a common date time here, and similarly you'll see for 4 o'clock that this is the values of the first company, second company, and so on. Similarly, to create the dataset window dataset for the LSTM, basically it takes the last k values and then predicts the next one. So this is the strategy used to generate that. So basically you will iterate into this way and then basically append index to index plus window size basically, and then we will take the first column. Basically first column will be the output, basically the closing price in most cases, and the rest of the thing will treat as exchange. So here you can see for this particular data, so given the window size as 4, so we will have a 3 window thing. So given this input, so 0 you can see here, given these 3 as input, 0, 2651, 2836, 281962. So these are the 3 inputs for now, and then the output would be the next one, basically this 2894, this one. So you can just see here. So given these 3, basically it takes these 3 rows and then it predicts the next value of the closing price. The first column would basically represents the closing price. So this is basically the next closing price. So your input would be these 3 rows and the output would be the next row of first column. So we write a flexible data loader for training the LSTM. So we use the time series dataset, this particular class, which extends the dataset class of Torch, and then we perform basically the scaling which we showed earlier for using the standard scaler. Then we transform it. This is to generate it. We basically specify what are the companies you want to consider, and then the start and end timestamp. And while generating dataset, we will pass what are the rows we want to include, the training, validation, test sizes, the ratios, and the window size, and also the batch size, and whether we want to shuffle it or not. What is this? This is the strategy which I've shown. If we have more than one company, it will perform an inner join. Then it will convert it to a NumPy array. Then perform the window dataset generation, which I showed above. Then it splits the data into train, test, and validation. Then it converts it to torch tensors. Then we use the time series dataset class as I showed above, and then we print the shapes just for debugging. And then we use the data loader class of PyTorch and specify the batch size and shuffle nature. So here are some examples. So for example, if you only want the Apple's data and we only want closing and opening stocks, and we want this to be the time period, so this will create a data loader. Similarly, if you want Apple and Amazon, but your main company is Apple and then Amazon and only closing price. So we will have a shape of, and the window size by default is 20. So we will later choose 20 or 25. So you can see here that this dimension is 19, and the third dimension is 2 because we'll have closing price corresponding to Apple as well as Amazon, but one output only. So now for the training part. So initially we will train on only the closing price. So this is basically the data loader and model generation. This is the model. This is the function to train the model. It takes the number of epochs, the loader, the model, and the patience. So patience is for early stopping. So we will track the minimum value of validation loss over all the epochs, and then for each batch we will calculate the average value of train loss and validation loss and print it, and then we check if the validation loss is less than the least one. If not, if this value becomes more than the patience, we stop the training. So then here is the training. So chosen the patience as 10, and then we train it for 100 epochs, and then we store the weights in case there's an issue. So this function is to visualize the training results. It basically takes the data and then it predicts the value. But our scalar was trained on all the 4 types of data. So we'll convert it to a 4-dimension vector and then feed that to the scalar and take the third index because the third index was corresponding to the closing price. So that's what I've done. So here I'm just multiplying it with this one so that it broadcasts to that size, and then we basically take the third index corresponding to the thing. So and then we plot it. So you can see this is the actual data is the blue one, and the orange one is the training prediction by the LSTM. This is the training loss over the number of epochs. Similarly for test results, now instead of taking the training data, we take the test data and visualize. So and we just see this is the test data visualization of the, so blue one is actual and orange is predicted. Similarly, we have one more class just for prediction data loader. So we'll do the same thing as the previous part, but instead of splitting the data into test, train, and validation, we just use it for prediction. This is only for the last part, basically to predict on the next unseen data, basically. So let me show you an example later. So this particular function will predict, given this prediction data loader model and number of minutes for which you want to predict, it will just predict it for the next n minutes, basically this number of minutes. So let me just show you. This is the creation of that data loader. Then we'll do the same training for given all the other inputs. Earlier we only took the closing price. Now we'll take all of the 5 as inputs. Then we do the same thing. We do training. The shape will just be changed to 5 now instead of this. And yeah, so this is the training inference. So this is the test inference, and this is the predict data loader. Now we'll show it for since we trained it on 4 months of data, we'll predict it for the next 4 months of data. So you can see here that here while training I took from 2020 Jan to 2020 April end, and then for the predict data loader I'm taking it from 1st of May till for the next 4 months basically. So this is, and then we predict it for 100 minutes, 200 minutes, 500 minutes, 1 day, and so on. We calculate the MAPE basically to mean absolute percentage error to compare the prediction values. So you can see that this is the prediction for just giving the closing price as input. This is the prediction. Similarly, when we give multiple column input, we do the same thing, and then this is the predictions for, this is for 1 week into the future, this is for 1 day into the future. Similarly, 2 weeks into the future, 1 month into the future, and so on. We will be comparing the performances in the 8th part basically. So yeah, this is the module which performs the trading. So in the algorithmic trader, what we do is we take in the initial money commission and bias spread as parameters. This particular function will return the net worth of the person. Given a price, it will give you the current money plus price into number of stocks. So for buying, we'll simulate the buying in this particular fashion. We'll check if there is sufficient money, and if so, we'll buy the stocks. When we buy the stocks, we'll subtract the money with the price into the cost of number of stocks. We'll also subtract the commission. And while giving in the price, we'll already take into account the buy ask spread also. I'll show you later. Similarly for sell, here we will take the number of stocks price, and we'll check if the number of stocks we wish to sell is more than the number of stocks we actually have, and then we do the same. So this function returns the maximum number of stocks which can be bought for the given amount of price and the amount of money which you have. This is for reinitialization after training. I'll show where this works later. This will basically set the current minute to 0 so that we can do that. So I'll show you later. So what the trade function does is, we can pass it a trade after thing, which basically says after this many minutes you can trade. So if I pass it 10 minutes, so it will trade after every 10 minutes. So and then maximum interval is for how much time I want to trade it. So for example, if I want to trade for 1 day at intervals of 10 minutes, I'll pass this as 10, pass this as 1 day. And then number of stocks which I trade normally. And then there is 2 parameters called mean profit threshold and max profit threshold. I'll explain what they do. So what we'll do is every time we will predict it for the time current minute plus trade after, means after 10. For example, at 0 we will predict for 10, and then we get its value, and then perform the same scaling and inverse transform of the scaling, and then get the value of the price. And also we'll keep track of the global maxima of current price till now. So this is just to make sure that small disparities, small going down will not cause our model to trade badly. And then we will predict the expected number of predicted profit. Basically, we'll get, this is the prediction. Basically, this is the current price plus bias spread into number of stocks we wish to trade, and we subtract the commission. So and what logic I'm using to trade is that if this predicted profit is more than this maximum profit threshold and this prediction value is more than the global maximum of the price, in that case buy as many stocks you can from the money which we have. So this does that. Similarly, if this profit is more than minimum profit threshold and prediction is still greater than global maxima, then but it's not more than the maximum threshold, then buy the normal number of stocks which you buy always. Else, if your predicted profit is negative or anything, just sell all of the stocks that you own. So this is the basic logic that I'm using for the algorithmic trading, which makes use of this LSTM. On the other hand, we have the buy and hold trader. It has many functions which are similar, but what it does, it just starts and buys how many stocks possible from the given money, then stays, waits for the entire time, and then holds the money, holds the stocks for that entire time, and then sells it after some time. So then we can pass the commission and bias spread as parameters. So given I tried to do it without that, without the bias spread, and we can see that start net worth was 1,000, 10,000, and then end net worth was 10503. Similarly, here 10,000 is input and 10537. So and here again, this is for the normal buy and hold strategy, and it's 10321. So we see that when there is no commission and bias spread, these two are performing much better than the buy hold strategy. Similarly, if you see here, single input feature LSTM, we are giving the said bias and the commission and bias spread here 1 and 0.05, which is 5 cents and $1. Then we see 10329 here and 10379 and 10304. Still, these two are performing slightly better than the buy and hold strategy. So now we will test it on actual data, which is not seen basically by the LSTM. So what strategy we will be using here is, so first we will to see how the prediction error varies from the last time it was trained. This function basically takes, we did a prediction for the 4 months right here. So we are basically storing the value of the error into this multiple MAP_vec, and similarly for single. So what we can visualize is that over time, since we are not training it, over time the error should increase. So we see that it is increasing. And on the other hand, if we have multiple inputs given as input to the LSTM than a single input, we see that it is performing much better than the single input one for smaller durations of time. But as the time duration increases, it kind of reverses. So this is what is mentioned here. And so to test it on a long duration on later years, we will use the following strategy. So we saw that the error is becoming very large even after 1 month or 2 months. So what we will do is, instead of training it on a very large time, we will train it on 4 months, every 4 months. So we'll train it on the past 4 months and then trade it for the next 4 months, and then again train on that new 4 months and then do it for the next 4 months and so on. So, but for the normal buy and hold, we'll just buy and we'll hold it for the entire year and then see what happens. So for the buy and hold trader, so we're just initializing with $10,000 and then we buy and we hold for entire 1 year. So it bought 75 stocks and sold 75 stocks after 1 year, and this was the amount of money. And this is without commissions, this is with commissions. So you can just see that it is very comparable, because since you're only trading once, it shouldn't cause much issue. So now we'll do the algorithmic trader. So we will train it first on the first 4 months of the previous year. That is, so we are doing it for the year of 2021. So we'll predict it on the last 4 months of 2020 first. We'll train it on the last 4 months of 2020. Then predict for the first 4 months of 2021 using that. Then train on 2021's first 4 months and then use that to predict the next 4 months and so on. So that is what is happening here. So these are the training data loaders. These are the prediction data loaders. So the first prediction data loader would be just from 2021 first 4 months and so on. So this is the dimensionality. We will go with the five inputs, basically all the inputs of the thing as input, and then so first we are training it on the last 4 months of 2020, and then after training we are just trading it for that 4 months. Similarly, then we'll train it for the next 4 months, and then trade for next 4 months. This reinitialize after training is that I was telling that time, right? So this function basically gets rid of sets the start time to 0 so that there is no index errors when we do the trading. So then again we are trading it for the next 4 months, and then we are training for the that 4 months, and then again we are doing that for the we are training it for the last 4 months. So we see that in normal trading we had got the buy and hold strategy, we had got 13091, 13082. Now similarly we see here that 14842 is the amount. This is this is intermediate value. So you can just see here. So we started with 10,000, then it became 11437 after the first quarter. Then 11437 we start with that, and then the next quarter, by the end of the next quarter, it becomes 14842. Similarly here 14842 was input and 18350. So we see that this profit is way higher than what is being done just by the buy and hold strategy. So buy and hold strategy, it is 130 something. Here it is 183. So what conclusion we can do is that the algorithm with charges, without charges, performs better than the one with the charges, which performs better than buy hold without charges, and which performs better than the buy hold with charges. So this is the conclusions. And for the advanced part, now what we are doing is we will be using multiple stock prices as input to predict the price of Apple. So we will use AMD and Apple's price to predict Apple's price. So now I'm passing Apple AMD using those functions which I declared in the start, and then passing AMD as the other company. So, and I'm using all the 5 prices input. So thus you can see the shape, window size of 25. So you have 24 as the second dimension, and 10 because 5 prices corresponding to Apple, 5 prices corresponding to AMD. So now let's see. So we train it for this much time, and then we store the value, and then this is the training. This is the test. And future predictions we do using this now, and then we'll plot it alongside the ones which we had plotted earlier. So multiple stock AMD plus Apple. This green one is the one for the thing. So we see that multiple it performs very good in the for small values of not being trained, and then continues to perform well. On the other hand, just using a single input becomes worse after 2 months, after 2 weeks. So these are the inferences for that. Similarly, now in the last part 9, we need to add time and day, week, and time as inputs to see if it improves. So what strategy we will use is we will extract the day, week, min, and hour from the index. Basically, this is the index, right? So this will end up creating day, week, min, and hour columns to the data frame, and then we'll perform normalization based on the size. So days will be from 0 to 31. So we'll divide it by 31 and so on. 52 for weeks, and then for minutes it is 60 and 24. So this will just scale it down, and then this will be our data, the numpy arrays. Now we just modified this old data loader just to add this code here. So this is the same as the old data loader, but this is the additional code which has been added to make sure that time data is also added to the data loader. Similarly, for the predict data loader also we are doing the same thing, just adding these lines extra. So now when we create the data loader sites, we'll have these 5 columns as well as 4 more columns corresponding to the data. So we'll have 9 columns here, and we perform input dimensionality just changes. Everything else we keep as same so that we can compare. We perform training for 100 epochs, then we observe the test and train data, and thereby we can just see this is the predictions, and then finally we do the comparison. So when we do the comparison, this is what we get to see. We see that the multiple input with daytime data performs very good in the start, but it becomes horrible towards the end. But it still performs better than the single input for a small value of 2 weeks. But as the value increases, I think it becomes worse. Hence, so what we finally infer among all these 4 methods is that the red method, the multiple input method, is the best method, and since it produces the least amount of error across all the various time intervals for which we have trained, which we have tested on, and followed by the green one. Green one is multiple stocks and multiple inputs. So AMD plus Apple. This, I think, what the reason for this part is that since we are performing inner join, many data points are lost because we might not have data points corresponding to both companies. Hence, it's getting rid of those points. Hence, it's not performing as well. Similarly, the third part, I think, third best would be the multiple input with the data frame time data, and the last one is single input. So you can just see this. So this is the conclusion of all the various parts. Thank you so much for listening.